Layers of Earth's atmosphere. At the end of this module, you will be able to describe the 5 layers of Earth's atmosphere. The Earth is surrounded by a layer of gases called the atmosphere. Earth's atmosphere is divided into several distinct layers. The 5 main layers of Earth's atmosphere are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Let us learn more about each layer of Earth's atmosphere. Troposphere is the lowest layer of the Earth's atmosphere. Troposphere is the dense, moist layer closest to the Earth's surface. This is the layer where all the life forms exist and the phenomenon of weather takes place. The layer above the troposphere is called the stratosphere. Air in this layer is less dense compared to troposphere. Stratosphere includes the ozone layer. Ozone layer protects the Earth from harmful ultraviolet rays of the sun. Jet aircraft generally fly in this layer. The third layer is called the mesosphere. It is known as the coldest layer of atmosphere. Meteoroids burn up in this layer and hence do not reach the Earth. Thermosphere is the fourth layer of atmosphere. Ionosphere is a part of this layer. It consists of electrically charged atoms called ions. These ions help in radio broadcasting by reflecting radio signal back to the Earth. Exosphere is the outermost layer of the Earth's atmosphere. It extends to the outer space. The air is very thin in this layer. Artificial satellites orbit the Earth within this layer.
If the Earth were to be an apple, this layer of air would be no thicker than the apple skin. The composition of the atmosphere has varied throughout Earth's long history. Today, about 99% of the volume of clean dry air consists of 2 gases, nitrogen and oxygen. The nitrogen gas that makes up 78% of the volume of air cannot be used directly as a nutrient by animals and plants.
What do you think goes unseen, though it is present everywhere? Just a little of this can move around freely, filling an entire building. At the same time, it can stay captive inside a tiny jar. Can you guess what we are referring to? Yes, it's the air. Air is present everywhere around you, in your classroom, in a bottle of juice, in a heap of sand, and even in an empty glass. Air is indeed very strange. Come, let's discover the properties of one of the most essential resources, the air. At the end of this module, you will be able to list the properties of air, conduct experiments to test the properties of air, state a few applications of air pressure. Air has mass, hence it has weight. Let us verify this property of air with the help of an experiment. You will need 2 fully blown balloons, 3 pieces of string of equal length, a sharp pin, and a ruler. Tie the balloons to the 2 ends of the ruler with strings. Loop a string at the center of the ruler and hold it up. Now, burst one of the balloons with the pin. The air in the balloon rushes out. You will find that the balloons are not balanced anymore. The side of the ruler with the balloon containing air tilts down. This proves that air has weight. Like all other states of matter, air occupies space. Let us conduct an experiment to verify this property of air. You will need an empty bottle, a paper tissue, and a big bowl of water. Roll the paper tissue into a small ball and push it into the bottle. Turn the bottle upside down and dip it into the water in the bowl. Water does not enter the bottle and the tissue stays dry. Now tilt the bottle to a side. As you can see, air bubbles rush out and water enters the bottle, and the tissue becomes wet. Why did bubbles come out of the glass when it was tilted? What were the bubbles made of? Air in the bottle prevented water from entering it when the bottle was held straight. When the bottle was tilted, the air in it escaped in the form of bubbles and made way for water to enter. This experiment clearly shows that air occupies space. What makes leaves and dust fly in breeze? Air exerts pressure and makes things move. Let's conduct an experiment to verify this property. You will need some colored liquid and a medicine dropper. Pinch the rubber handle of the dropper to expel air. Place the dropper in the liquid and release the handle. The liquid rises up in the dropper. Now pinch the rubber handle. The air in the rubber pushes down the liquid in the dropper and forces it out. This shows that air exerts pressure. We often apply the properties of air in everyday life. If you look around you, you can find many instances where air pressure is put to use. Here are a few such instances. The sounds produced by instruments like the flute and whistle. The use of droppers and syringes to measure and administer liquid medicines. Straws to suck in liquid. Air guns to fire out pellets. Flying kites, etc. work on the property of air pressure. Here is a simple concept map showing the properties of air.
Hello students! Have you ever wondered why the size of a balloon increases when you blow air into it? When you blow the balloon, the air exerts pressure on the walls of the balloon, causing it to inflate. Does the weight of the balloon also increase when it is inflated? Let's take a look. If we hang a long stick from its center, with an inflated balloon hung up at one end and a deflated balloon at the other, it tilts towards the inflated balloon's end. This happens because air is present in the inflated balloon and has weight. Now, what about the air that is present all around our planet? We know that Earth is surrounded by a blanket of air called the atmosphere. This atmosphere extends up to 10,000 kilometers from the surface of Earth. Air has weight, and therefore the atmosphere exerts weight on Earth. It is because of this that every object experiences a downward push due to the air above it. Such pressure exerted on the surface of an object by the atmospheric air above it is called air pressure. When there is more air, there is higher pressure. Similarly, when there is less air, there is lower pressure. Let us see how the air pressure changes according to the height above sea level. Consider a person standing on the ground at sea level. The atmospheric air in the space above the person will exert more air pressure on the person. If the person climbs a mountain and reaches a height above sea level, the air in the space above the person will get reduced. Thus, the person will experience less air pressure. So, we can say that the air pressure decreases as the height above sea level increases. When there is low pressure in a region, it usually leads to cloudy weather, wind, and precipitation. When there is high pressure in a region, it usually leads to fair and calm weather. Let us summarize what we have learned. The pressure exerted on the surface of an object by the atmospheric air above it is called air pressure. When there is more air, there is higher pressure. When there is less air, there is lower pressure. Air pressure decreases as the height above sea level increases. Bye-bye.